Alright, this is our second video about solving systems of equations using elimination. Alright, so let's look at this example. And actually for this example, we're going to do this problem twice. We're going to do this problem using two different ways, right? Both elimination, but we're going to look at this problem differently the second time around. Alright, so first let's start with kind of the most obvious way to do this problem. Alright, so you'll notice if we want to use elimination, right, we want to get one of the variables to eliminate. And it should be pretty obvious in this one which one is going to eliminate. Right? If you take a look at the x's, the x terms, right, you'll notice that they have opposite coefficients. Right? The first equation, we have a coefficient of positive 2. The second equation, we have a coefficient of negative 2. Right? So if I add those two equations together, right, the x terms will be eliminated. Right? Because 2x and negative 2x, when I add those, that's 0. And then when I add the y terms, 5y and negative 3y, that's 2y. And then we have 17 plus negative 7 is 10. Right? So we end up with this simple equation, 2y equals 10. Right? The x terms were eliminated. Right? And we can solve this one really easily. Let's divide both sides by 2. And we have y equals 5. Right? But we're not done. We still need our x value. So we're going to substitute this y value of 5 into one of the two original equations. Doesn't matter which one you use. Let's go ahead and use the top one. So we have 2x plus 5y is equal to 17. And we can replace y with 5. So let's replace y with 5 here. And we have this, 2x plus 25 is equal to 17. Let's solve this one. Let's see, I'm going to subtract 25 from both sides. We end up with 2x is equal to negative 8. And now I'm going to divide both sides by 2. We get x is equal to negative 4. So our answer would be negative 4, comma, 5. Alright, so that's the easy way to do this problem. Right? And we have our answer. This is the place where the two lines intersect. This is also the ordered pair that would satisfy both of these equations. Right? But now we're going to look at this problem a second way. Right? So same exact equation. Now what I want you to think about is how could we do this problem if we wanted to eliminate the y's instead of the x's? Right? And obviously in this problem it's easier to eliminate the x's. But it's not always going to be set up that way for you. So I want us to think about how we could eliminate the y's in preparation for the harder problems where it won't be so easy. All right, so let's think. In the previous video, we showed you how to multiply equations by a constant so that we would end up with opposite coefficients. Right, but for this one, if I want these to be opposite coefficients, there's no integer number that I could multiply 5 by to make that become positive 3, which would be the opposite of negative 3. Right? You could use a fraction, but you're not going to have a nice integer that would work there. Right? Same thing for this term. Right? There's no easy integer that we could multiply negative 3 by so that it would become negative 5, which would be the opposite of 5 up there. Right? So there isn't an easy number you can just multiply one equation by to get opposite coefficients. Right? Instead, what we're going to need to do is we're going to need to multiply something to both equations. We're going to need to multiply both equations by a constant. All right, so let's think about the numbers, the coefficients here. We've got positive 5 and negative 3. Right? We want to try to make these opposite coefficients. Right? And what we can do is we can multiply 5 by positive 3. That would make this 15. And then if we multiply the bottom one by 5, we'll have negative 15. Right? And 15 and negative 15 will be opposite coefficients. All right, so let me show you so that that'll make sense to you. All right, so let me do this over here. We have the original equation, which was, oops, let me change to pen, 2x plus 5y equals 17. And what I'm going to do is I'm going to multiply that equation by 3. I'm going to multiply both sides by 3. And then the second equation was negative 2x minus 3y equals negative 7. And I'm going to multiply this one by positive 5. Right? Why did I do that? Again, the reason why I did that is so that the y terms will have opposite coefficients, right? Because 3 times 5y, that's going to be 15y. Here, 5 times negative 3y, that's going to be negative 15y. All right, so let's see what we get. We should get 6x plus 15y equals 52. That's the first equation. And then when we multiply the second equation, we get negative 10x minus 15y equals negative 35. Oops, I'm sorry, I messed up. That should be 51. Okay, so 6x plus 15y equals 51 for the top one. And then the second equation, we have negative 10x minus 15y equals negative 35. Right? And again, we accomplished our goal because right here we have opposite coefficients. We've got 15 and negative 15. Right? That's what we wanted. So let's go ahead and add these two equations together. We have now negative 4x. This is going to be eliminated, so plus 0y equals 16. So the y's are eliminated, so we have negative 4x equals 16. And then if I divide both sides by negative 4, we get x is equal to negative 4. All right, not done yet. Let's find our y value. Okay. All right, to find the y value, what we want to do now is we want to substitute this value, x equals negative 4, into one of our original equations. And you can technically plug it into one of these equations, but just to avoid any mistakes, I would always recommend plugging it into one of the original equations. Right? So let's plug it into one of our original equations. Why don't I go ahead and plug it into the first one, right, which was 2x plus 5y equals 17. So I'm going to replace my x value with negative 4. So I have negative 8 plus 5y equals 17. If I add 8 to both sides, we have 5y equals 25. And then if we divide both sides by 5, we have a y value of 5. So our answer now is the same as what we got the first time, negative 4, 5.